Hello, everyone. Welcome back to Kira Cloud Hub, my YouTube channel. And Raji, I'm actually excited to have you join us for part two of our Amazon Bedrock series. So, if you caught the first part, we dived into the basics of Amazon Bedrock and why LLMs are changing up the game. Okay, so now we have something more exciting lined up, and Raji will tell you about it. So yeah, grab your favorite snack, get comfortable, get some coffee like me, and let's dive into part two of Amazon Bedrock. So Raji, if you're ready, you can just come in, let us know what we'll be discussing today, and get started.
Thank you, Pauline. Thank you. And it's always exciting to talk in your channel. Yes, so last week we just got introduced to Gen AI and Amazon Bedrock. So this week we are going to talk about something called vector embeddings, which
Mhm.
is quite important in the world of Gen AI. And also we'll see how vector embeddings can be generated in Amazon Bedrock. And there are ways in which you can chat with your documents. So we are going to create knowledge bases in Bedrock, and we are going to see how we can use them. So that's what I have in plan for today.
Awesome. Thank you so much. That's amazing. So let's dive right in.
Yeah. Vector embeddings is something which I want to start today's session with. Um, Now, deep learning models. So, as we discussed last week, uh, generative AI is because of all the capabilities deep learning models can do. It's one of the technique of deep learning models. But these models, like not just deep learning models, computers in general, they don't understand text. So if you want to make sense out of an image or a text or a video, you cannot directly feed into a computer system. So you have to convert it into numbers. So they understand only numbers, right? So now, how do we make our deep learning models process or interpret the content within documents, within videos, within text? So that's where vector embedding helps us. So it is a technique. It is a technique to process or to turn the information, turn text, videos or pictures into numbers, into something which the deep learning models can process. They can use them. So that this is one of the technique in which it helps us to convert to a format that the models can understand. So when I say format, what it essentially means is any word. So for example, if you take rows, that is something which we understand. But for a deep learning model to process it, you need to convert the word rows into these numbers. So these are just a sample. So it would be a huge list, and it would be multi-dimensional. So it's a huge array of numbers, and that is what a deep learning model can process, right? So what happens next is now, because you can convert all of these words into numbers, you also need to notice that you can do, there are two types of search which comes now. So there is one search called semantic search. So when somebody asks us to find words which are similar or which are in the same category as rose, so we would say it is a flower, it has petals, there are other flowers like tulip. So we do a semantic search. So we know what a rose means. It means a flower. We also know what are the other flowers similar to rose. So we humans do a semantic search. But whereas computers, if you tell them, if you tell a system to find a word similar to rose, it will do a dictionary search. It's called lexicographic. So it will give you results like rope or rosary or roses. So it will literally do a dictionary search. It cannot understand that rose is a flower, and the tulip or a lily can also be an answer when somebody asks similarity or similar flowers like rose. So it cannot interpret the meaning of rose. So that's where converting the words into numbers helps us. So when we start, converting all of the words into numbers, and when you compare these arrays, the computer system will be able to understand that yes, there are similar words. So for example, every word that you have, say if you take happiness, when you convert into a number, which is called as vector embedding. So this is nothing but an array. So it's converted to something like a three-dimensional. So it's not necessarily that's always three-dimensional. There are multiple dimensions which you can have, and each of the number within this array, they represent a meaning. So for example, when you take 2.5, it actually has a meaning attached to it. So it could be color, it could be size. So there are various traits which are represented as numbers. All right. So now you take all of these flower names, right? So rose, you have lily, you have lotus, and you pass it through an embedding model. So embedding model is the one which creates the vector embeddings. So rows could be, say, converted into an array which is 0.6, 0.3, 0.9, where each of these squares are a trait of the rose flower. So similarly, other flower names are also converted into vectors. Now, what the model will do is it will compare one array with another, and then it will be able to understand which array is closest. And that's how it will be able to tell you that these two words are similar, or these words have totally opposite meaning. So that's how the linguistic features come out. So that's the basic fundamental concept behind vector embeddings. Now, there are various ways in which these similarities, so we call it as, it's called semantic search. So once you convert the words into vectors and finding the similar words, it's actually a mathematical calculation. And there are two techniques which are very common. So one is the cosine similarity. So what essentially happens here is you plot the vectors in a graph, and you measure the angle between two vectors. So two vectors are nothing but two numerical representation of two different words. So as you can see here, now there are three traits here: gender, age, and royalty, right? And you plot the vectors in a 3 dimension. And if you see here, the girl and the woman. So the girl and the woman are related to each other in the trait of age. So as a girl grows up, she becomes a woman. And the boy and the prince, they are related to each other on the trait of royalty. So in order to find what is the closest, so when you give an input to this 3 dimension, say you give an input as princess. Now, if you want to see which is the closest to princess, then you would get queen. So you basically calculate the angle between the two vectors. So if the angle is small, then it means that the words are similar, semantically similar, or they mean the same. There is another technique called Euclidean distance, though this is not, at least I didn't see much being used. But yes, I just wanted to bring it to your attention that there's also one more technique where the straight line distance between two vectors is calculated. So smaller the distance, it means they are more similar. So that's about, that's, I mean, you don't have to get deep into these techniques. We are not going to use it when we create knowledge bases in Gen AI. But it's good to know that how this calculation happens behind the scene. So all of this is done by LLMs. So in today's session, we are going to see how the LLM is calculating the cosine similarity. And when you give an input phrase, it will tell you which phrase is closest to it. So we are going to play around with a small exercise. These are few other examples which I just picked up from internet sources. So you basically you plot these vectors and you calculate either the cosine similarity technique or the distance technique. Based on that, you will be able to infer which word is closest. So if you see here, male, a female, right? And then verb. So based on the tense of the verb, these two words are similar. Then country and capital. So I've given the source links as well. So if you want to have a deep understanding of this, you can visit these links. So this is another example. So now we saw for words. So similarly, you can keep doing for sentences. So for example, if you have how old are you as a sentence and you input into an embedding model, it will generate these vectors. What is your age? This is the vector. Right? And then when you start plotting for various sentences, so in this graph, you can see how old are you is plotted here. And similarly, the other sentences are plotted here. So with this, higher the score, you will know that the two sentences are semantically, they mean the same. So there are, it's not just for words or text. You can do for graph databases, graph information. You can do for images. You can also give in a whole document. Now, for each of these type of vector embeddings, there are various models, embedding models, which you can use. So if you want to convert a word to a vector embedding, you can use word to vector, glove. If you want to convert sentences, you can use sentence word, or you can use universal sentence encoder. So similarly for image and documents. Now the practical uses of vector embeddings, they are many. Right? For example, you can create recommendation engines which can tell you what are the similar interests which other people had. It will also help you for retrieving information. So you can feed in a huge volume of documents and you can literally chat with those documents. So you can give prompts, you can give keywords, you can ask questions. So you don't have to go through the pain of reading every page of the document. So similarly, you can feed in audio files, speech files. Transfer learning is another interesting application of vector embedding. So you can literally transfer the learning from one system into another. And not only that, you know, the way you compare an image with another image, you find out which is a similar image. You can also do the same for facial recognition. So you can vectorize the human face, and you can find out the most closest or a similar face. So this is applied in facial recognition use cases. So these are just some of them, but yes, the list is growing as we speak. So in a nutshell, vector embedding is a technique which helps you to convert multidimensional data. So the traits that we saw for, say, a flower or a princess to a queen. So there are traits like age, gender. So there are, these are the dimensions which I'm talking about. So there are multiple millions of dimensions. And using vector embedding, you can convert high dimensional data, a multi-dimension, into a lower dimension that still maintains the same meaning and the relationship with the original data. So that's how deep learning models or computer systems are able to find out which is what are the similar data, and they group them together, and that's how they are able to tell you the most matching or the most similar meaning sentences. So we'll see a demo with Bedrock where we can give in few sentences, and we'll see how the most similar sentence is being given out as an output. Yeah, so over to our demo. Going to Bedrock here. And we saw a glimpse of it in the last series. So here we have the models. And for the vector embeddings, you need to choose by modality, like you group it by modality, and you will be able to see what are the various embedding models Bedrock has to offer as of now. So Bedrock has Amazon models, and they have Cohere models. So we can use one of them. So we can use, say, the Titan, Amazon Titan model, and this is the model ID. And this is the signature of the API request. So it takes a JSON as an input. And in the body, it needs this keyword input text, and then you give your input text. So I have written a small program just to see how this embedding looks like. Okay, so yeah, so first you instantiate the Bedrock runtime client, and then you input the model ID from here. So that's your model ID. And then you can have an input text. So say I have a text called I like rose flowers. Now I'm going to see how this sentence I like rose flowers looks like when it is converted into a vector embedding. So this is the line which converts into JSON, because as we saw here in the API signature, it needs a JSON. So it needs the input text to be first converted into JSON. So that's what we are doing here. And then we are just calling the API in the way that it expects. So this is the response object. And then you read the response object. Okay, then and then you print the response. So here I am printing the response as a JSON so that it's easy to interpret. All right. Okay. So let me go to the directory. So the class is create embeddings. So here I have hard coded the input text. I like rose flowers. As you can see, the phrase I like rose flowers have been converted into vector dimensions. So this is the array of numbers. It's a long list. So it goes on, and yeah, at least you can make a sense of what is happening behind the scene, right? So say I change it to, I just give one word. All right. So this is the representation of the word morning, and it also gives you the token count. So token count, we saw it in the last video. How do we know whether like what is the count of token? So I showed you an OpenAI tool which you can use, where you can input your phrase and it will tell you the count, the token count. So here it also gives you the input text token count. So that's the way these embeddings are generated, and that's how these it looks like. So now I'm sure you are getting an idea. So basically, the models just compare this array with one another, and they will be able to understand the similarity between the various words, which is nothing but the semantic search, the kind of search that we humans do. All right. So that's about creating an embedding. Next, we will also do another demo where we will be creating a knowledge base. But before that, I have one interesting uh, code where we also do a similarity search. So we will be comparing two sentences. And if you remember, I was talking about cosine similarity technique. So we'll see that in action. Okay, so here is another program which I had written I'm using NumPy package, and I'm using the same Bedrock object. So what I'm trying to do here is I have some facts about flowers. All right, so I have written some facts which I have hard coded, and I'm going to do two things. So I'm going to input one sentence, and then I'm going to have another sentence which is a question. And using the cosine similarity technique, so this is nothing but a calculation, as we saw, and I'm going to use this calculation, and I'm going to infer which two sentences are similar. So you can take this code from my Git, and you can also experiment with various other sentences and see how it basically conclude that two are similar. All right, so I'm using the same Titan model here, and pretty much the way we did in our last program on calling the API and then returning the response, and then we are calculating the embeddings, and we are going over each embedding, and we are giving a score. So let me run the code so that you get a clarity. So these are our two sentences, all right? And this is the base, okay? So you can treat this as the knowledge base for this program. And these two are the inputs or the prompts that we give. Okay. So these are the set of facts, and I'm adding a new fact that tulip is lilac in color, and this is the question. So what do we see here? Now it is comparing the similarities, comparing with new flower fact. Tulip is lilac in color. So what it is essentially doing is it is taking this sentence and it is comparing the similarity with these sentences, and it's giving a score. Okay, so it is taking this sentence and it is comparing each sentence and giving a score. So tulip is lilac in color is compared with this sentence, and it is ranking it high, and it's showing a similarity of 0.8, which means that this sentence and these two sentences are the most similar one, and it's able to conclude that the similarity score is 80%. And it is doing that the same with all the other sentences, and it is ranking based on the similarity score. So next, the most similar sentence is daisies. So daisies symbolize innocence and purity. So that has a similarity score of 0.59. So it keeps doing that, and then based on the score, it has ranked. Now I have this question: where is marigolds grown in India? Right. So let's see what it has to say. Now, none of these facts or this fact talks anything about marigold nor India, right? So there are no similar sentences. So if you look at it, the similarity score is very less. It's 0.38, and the score keeps reducing for the other sentences. Now, assume I ask a question which is from these flower facts. So let me ask a question about rose. I'll ask a straightforward question. Okay. Which is the most popular flower in the world? Now, what should I ideally get is the answer for this question is here. So this should have the highest score, right? So let's see. Okay, so yeah, so which is the most popular flower in the world? So here it is comparing with the flower question, which is the most popular flower in the world. And you can see it has ranked 0.81 for roses are one of the most popular flowers in the world. All right. So that's how the similarity scores are calculated. Now let me give something totally unrelated topic. Okay. Now, this is totally unrelated. It has nothing to do with any of these facts. So the similarity score should be very less. Okay. So if you see here, which is the capital city of UAE, the similarity score comparing with flower question, the similarity score is just 0.15. Then it keeps reducing 0.08, 0.07. So pretty much there is no answer for this question from these facts. So I hope you are able to follow, and as I said, you can also take this program, probably extend it, and also play around with the phrases to get more comfortable about the calculation and the similarities and how this embedding works. Okay, so that was on the embedding, and then next we'll move on to how these embeddings are applied in Gen AI, and how we can chat with or literally communicate with the documents in Bedrock. So Bedrock has something called knowledge bases. So here in knowledge base, what you can do is you can upload, like you can create your own knowledge base and you can have a set of documents which would serve as the repository. And you can, just like how you chat in with the Gen AI model, you can chat with your documents. So that's what we are going to see here. Just let me create a knowledge base. I give a name. And give some description. You can either use a service role or create a new one. So it is also possible to store the data in other sources as well. So you can also crawl some websites, or if you have any external system. So it's very common for organization to store their documents in SharePoint or Confluence. So you can also integrate with such data sources. Okay, so this is S3. I already have a S3 bucket where I have uploaded these PDFs already. So I'm going to use that. Yeah, so this is the one. Let me just check if it is. Okay. Yeah, so this is where this is the bucket child labor docs where I have uploaded all of these documents. So let me choose that bucket. So I'm going to choose the whole bucket. So all the documents in this bucket will become my data source. And then I can just keep it in default. So basically what it does is it will be chunking, it will be breaking down the documents into smaller fragments, which is nothing but the chunking. So there is a technique for chunking. So it's I'm going to go ahead with the default technique. So next step, once these documents are chunked, it should be fed inside an embedding model, because that is what is going to convert the text into numbers. So I can go ahead with any of the embedding model. And once the model converts the text into numbers, it has to be stored somewhere. And there are a number of vector databases available. But here in AWS, you have OpenSearch, and I'm going to go ahead with that. But you can also choose if you want to store it elsewhere. So a very common, well-known vector DB is Pinecone, and there is also MongoDB, right? But I'm just going to go ahead with the default selection. So here, when I say default, it's nothing but the OpenSearch serverless vector. And just review the configurations, and then I create. Okay, it's got created. So okay, so you can see here the knowledge base is created, and it shows you the S3 bucket where the PDFs were stored. You can see the ID and other details here. So before you start using this knowledge base, you need to sync the data source. So syncing will take few seconds, of course, depending on the volume of the data. So it also tells you what is the embedding model, the vector dimensions, and the DB details. So you have a Bedrock also offers a small test module where you can have a quick chat with your with your knowledge base. Okay, so yeah, so that's our knowledge base. Now let's go to the code with which we are going to communicate with this knowledge base. So for that, what I'm going to do is I'm going to use the Boto 3 client package. And it is important to understand the kind of APIs that Amazon Bedrock offers. So it's working now. Okay, so as you can see, you get the output. I'll show you what I had configured. So this is the prompt. What are the child labor laws in India? Right. For this input, this is the output that we are getting. So it has searched one of the PDF and it is getting the output. Okay, so that's how you communicate with your knowledge base. So next, what we are going to do is we are going to add a small interface, a Streamlit chatbot ahead of this Lambda function. So I have created a API gateway which will invoke this Lambda function. So this is the API that I have created, and it's a simple integration. It's calling the Lambda that we created now, and I created a post method. So all the other configurations remain the same. Just ensure that you have the right text in the mapping template. So once you do this, it should work. So this is the chatbot. This is a Streamlit application, very much similar to what we did last time. So here I give the API URL and then the payload and the headers, and then the chat history. Okay, so we are also maintaining the history in a session state. And then once the button is clicked, the send button is clicked, then it will add the chat history and it will call the API. All right, so let's see how this is in action. Okay, it is in. Okay, so this is the URL, and I'm going to. Okay, so this is the chatbot. Okay, so we know our PDFs. Let me just bring it up again. Yeah. So this is one. These are some of the PDF content, and yeah, this is one, and there is one more, which talks about statistics and other things. So there's also a Robert Kennedy PDF. So let me just try to ask some questions. So let's see. Okay, so it has brought some answers. Measures taken around the world for child labor include laws and policies to prohibit. Yeah, so it has taken from the PDF and it gives you the answer, right? There are also ways in which you can give the source. You can also make it to show you the source, the actual PDF from where it is taking. That's also possible. So let me give another prompt, which can bring something from maybe from this interview. Let's see if it's able to recognize few phrases from this interview. Yeah, so here you can see the interview with Kailash. So it discusses, so it has given a summary of what we see here in this content. Okay, so let's also see how it's able to interpret the statistics. Mm. Okay, so okay, so for this question, which talks about numbers, according to search results, the number of economically active children in India in the age group 5 to 14 was 1.26 crores. So it's also able to collect the numbers, so which is great, right? So here, this is that 1.26, right? So it has exactly fetched this number for this year, which I gave you, 2001, 1.26. So which is great, right? So it's able to get into the deepest detail as possible. So yeah, so that's about chatting with your PDF. There is a lot more that you can do. And yes, so you can take this base code and you can build on top of it and then enjoy your coding experience with Bedrock. So yeah, so that was about Amazon Bedrock's capability to chat with documents, knowledge bases, and then we'll see further how we can enrich and add more features in the next series. And any comments that you have, any feedback, or if you want to learn more, any clarifications that you have, you can drop in the comments of Pauli's channel. Over to you, Pauline.
Awesome. Thank you so much, Raji. That was an amazing session. I hope you all enjoyed it and see you in the next part of this amazing series. Do not forget to, like, subscribe, comment, share, all those things. Thank you and bye bye. See you in the
Bye.
next one.
See you.